Real-time reflection probes. Real-time reflection probes can come off. Hello, and welcome to the latest video in the How to Code a Game Like Minecraft series. This one is going to be a bit of a short one, and it's just going to go over a few little fixes and optimizations. There's a few things that have been cropping up in, say, the comments in Discord, little bugs and just general issues with the build so far. If anything doesn't get covered in this video, it doesn't mean that I'm ignoring it or anything. It's just, for example, there is some player controller stuff that I'm not going to cover in this video because there is going to be another video on the player controller in the near future, where we add things like field of view change when you sprint and a few other features to the character controller itself. And in that video, we will do a few improvements to the existing player controller. So for the first one, and I'm sorry, I'm just going to pull up Discord because I completely forget the username of the person who brought this to my attention. Bogdan55 brought this issue to my attention that I hadn't actually seen before, so I'll see if I can replicate it because it's a bit hit and miss. Okay, so the issue is if you place a block anywhere and then you move, sometimes the chunk disappears. And in this case, we had two chunks disappear because I placed a block across a chunk seam. And then if you move again, it's basically when you're crossing the boundaries of chunks and it's running the check view distance function. Every now and again, it's not 100% of the time, but it's replicatable. The chunks will just pop out of existence. So if you watch on if I just keep walking and pressing the place block button, you'll see at some point a chunk will disappear. This is what I meant about it not being replicatable all the time, but you saw it happen. So basically that is being caused, after a bit of debugging I figured out, by the fact that once again our threading is causing issues. Both our second thread and our first thread are accessing the active chunks list, wherever it is, this list here. It's been added to in both our update chunks function, which is called in the threaded update if you have threading enabled, but it's also called in our check view distance function, which is in the main thread, which is what's causing the issue. Is that every now and again things are getting a bit messed up. The quickest way I found to fix that for the time being is if we just stick a little check in here to say if active chunks does not contain the chunk that we are currently planning to add, then add it. So we're only adding it if it's not already in the list. If we try that now, one thing I'm just going to quickly do before I run this again is I'm just going to change the size of the world, or the draw distance, sorry, because I'm going to be loading and unloading the game a few times in this tutorial, and it's painfully slow to wait for the world to generate. I mean, you know how long proper Minecraft takes to load up a new world. We're essentially a much smaller world, but we're essentially doing this every time I press play. So I'm just going to shrink the world a little bit. So now if I do it, you can see the chunk doesn't pop out of existence. So I'm sorry about that, Bogdan, and anyone else who experienced that issue. Well, I imagine all of you experienced that issue. I don't think it's something that's system dependent. Maybe somebody with a faster or slower machine might have experienced it differently, but Bogdan was the first one to bring it to my attention, so thank you and sorry. So probably the next most commented problem I get is about the player controller. Basically, the bounds are not quite to everyone's liking, and you can sort of clip the camera through the planes there, which obviously isn't ideal. The reason I haven't addressed this before, well, I mean, I've addressed it in a few comments, but the reason I haven't said anything in a video is because this is just a matter of tweaking values that are easily accessible, which I will do now. There is another problem that I'm not going to address in this video, which is how you can basically ground the player at the side, like against a wall. So essentially, I can jump, if I just try and make a bigger wall here, it's a bit easier to demonstrate. There we go. Okay, so if I jump against that wall, I'm now sort of floating because the game thinks I'm grounded because I've managed to hit this wall. So basically, it's checking on one side of the player because we're doing these 4 checks on each corner of the player's position, and it's finding that the player is in a solid block on one side. So then it's registering as grounded. Obviously, that's not the case because we're not, you know, we're in a wall. So we will fix that when we do the next player controller video. I'm not going to address that in this one. I just wanted to let you know that I'm aware of it. But as for the clipping and the bounds and everything like that, if we just head over to our player script, and actually I made these public, so we don't want to go in the player script, we want to go over here. So we'll make the player width 0.25, and then if we open up our player a bit, go to our camera, we're going to move the camera back to minus 0.15 on the z-axis. So you're never looking behind the player. Whichever direction you're looking, that is the direction the player is facing. So it doesn't matter if the camera is a little bit back from the front of the player, because it's not like you're going to turn around and suddenly be sticking out the back of the player. And then the final thing we're going to do to the camera is we're going to change the near clipping plane, so that's down here, to 0.1. So now let's give that a try. So now if I walk up to a block, you can see we're not clipping through it anymore. And just in case anyone here isn't aware, the clipping planes are basically the start and end of where the camera can see. So the far clipping plane, anything beyond that doesn't get rendered. Like the camera, it's kind of like having a view distance. Well, it is a view distance, but it's like a hard view distance. So no matter what's going on in the world, nothing will get rendered past that far clipping plane, which is a sort of a performance upgrade. If you know how far your view distance is in the world, in your Minecraft game, then there's absolutely no point in having a clipping plane further than that view distance. So you could bring the view distance, the clipping plane, backwards and forwards depending on the size of your world. And then obviously the near clipping plane is how close to the actual camera you can see. So before it was 0.3, so it was just a little bit further forward, so anything behind that doesn't get rendered. So we've just moved it a little bit closer to the camera. There's less chance of anything getting behind it and then, not rendering anymore. Now, to the bulk of what this episode is going to be about, the main thing that people have found issue with is performance. So we're going to do a few performance upgrades. Now, I won't drag you through the process of how I came to choose the performance upgrades that I'm about to show you. Needless to say, it involved a lot of going into analysis and profiler and seeing what was eating things up. Maybe we could do an episode on profiler another time. I imagine, most of you seem to know what you're doing, most of the people who watch these videos. So I would guess that most of you have had experience with the profiler, but if that's something you'd like to see a video on, then just let me know. The first thing we're going to do is we're going to look at our camera. We have on here a flare layer, which was just there from the default camera that's set up when we started the project. We don't need that. We don't technically need the audio listener, but I'll leave that there for now because we will at some point. These are minor performance tweaks, by the way. None of this is going to make a huge difference. These are all just little things that add up. Now, the second thing is we're going to do this for now, but obviously we're not going to keep these highlight and place highlight blocks indefinitely. At some point we are going to be changing them, but for the time being, both these cubes have a box collider on, which is obviously stupid. We do not need them, so remove those, because physics is probably the most CPU consuming thing, or GPU, I'm not sure which one it is. It's one of the most system intensive things that you can do after graphics. Maybe it might even be worse than graphics, it depends on the physics. But the problem is, like in testing, I found that those two little blocks were showing a significant amount of system resource usage. And when I say significant, I mean relative to everything else. Obviously, just having two blocks floating around in space isn't going to cause the system to lock up, but relative to the total usage of this build, those two blocks were showing up quite a high amount. So we're just going to remove those two box colliders. The next thing we want to do is we want to go into our world script, and just to save a little bit of time, we're going to cut this out and we're going to put it in a function, because right now we're setting that every time and we don't need to set it all the time, every frame. So we'll make it public in case we want to access it from anywhere else. Global light value. And we'll just paste that in there, and for now we're only going to call it once in our start. Sorry, that wants to be a void. So as this is now, if you change the global light value during the game, it won't do anything. Like if you change it in the inspector, if you change it here, it won't do anything. However, you wouldn't be changing it there in a proper game anyway. So what you could do is, if you want, for editor purposes, you could add an editor script to say, if this changes, run this function. But chances are you're going to be editing it in the script, in the code. You're going to be moving the time along as time goes on. So you would just simply, call that function in here at the appropriate times. So we're not going to put anything like that in yet because we haven't got a day-night cycle. For those of you who have got a day-night cycle, I know some of you have been experimenting with it. It's not going to be difficult for you to figure out how to do that, and it's probably not going to be much of a performance boost, but it's just an unnecessary call. Even if you have got a day-night cycle, you don't really need to call this every single frame. And also, if you have got a day-night cycle, you want to be caching your camera. Do not call camera.main every frame. That's incredibly inefficient. I'm pretty sure I said at the time that that's not the way we should do it. It was just a temporary thing. I'm not going to change it now because, like I say, this is only getting, in my build, this is only getting called once in the start menu, so it doesn't really matter. So now we want to go down to our check view distance for another little improvement. Here we are. And what we're going to do here is we are going to replace, and again, this is a very minor improvement, but every little helps. We're going to replace, see all these here where we say new chunk card, new chunk card, new chunk card. Every time we do that, it's a little bit of system usage that we don't need to be using. So we're going to make a new chunk card, which we'll just call this chunk card. And it's going to equal, and we'll just grab that. And then we will use that instead of making a new chunk card every time. Is that all of them? There we go. Right, so that's just a little, again, this is an every little helps kind of thing. So now we want to go into our chunk. And what we're going to do in our chunk is we go down to where we create the mesh. In our create mesh, we have this function being called. Now the normal, if you remember from I think the first episode, the normal is like sort of the direction the vertex is pointing. So in this case, the top face of a voxel, all four vertices that are on that face are all pointing straight upwards. And this goes through and basically does a best guess for which way a particular normal should be pointing. It works it out pretty accurately. Well, it works it out exactly on this particular mesh because all of the vertices in a given face are all pointing in the same direction. So it's fairly easy for it to work out what to do. However, this is an unnecessary calculation. We know which way the vertices are going to point because it's a cube. So we're going to create a new list. We'll go back up to the top. It's the same as all the other ones. Vector 3 normals equals new list. Vector 3. And then we want to make sure we add that to our various functions. So if we go down to clear mesh data, we need to put it in here. Normals.clear. And where is the create mesh? There it is. So instead of this, I'm going to say mesh.normals equals normals.to array. And to actually set those is surprisingly easy. Basically, we're adding, for each vertices, we're adding a normal value, and the normal for any given, so bearing in mind that this loop is each one face. Every time we go through all this code, that's one face. So we know that all the normals on whatever face we're adding are all facing the same way. For now, obviously, it's going to get a bit different when we add things like stairs and other shape blocks, but for now it's the same. So we can just say int I equals 0, I is less than 3, because this four faces 0 to 3, I plus plus. We don't need parentheses for this, it's only one line. And then we're just going to say normals dot add, and then because our face checks that we're using up here basically gives us the direction that we need to point anyway, we can just steal that. So voxel data dot face checks P, and that's going to add the normal for us, and that's all we need to do to calculate our own normals and scrap that entire function there. Now the other thing that we want to do here, and I did warn you guys that this would be coming back, having a transparent rendering material is more system intensive than having an opaque material, and right now as far as the game is concerned we have a transparent material or a cutout material or whatever you want to call it on everything, and obviously most of the stuff we're going to be looking at is going to be solid. Most of it's going to be grass and stone and dirt and things like that. So what we're going to do is we're going to bring back our second submesh. We don't want to use that as transparent. We're just going to steal this because we renamed that. So we're saying if world isn't transparent, add it to the triangles. If it is transparent, add it to the transparent triangles. Obviously that means that we need to bring back all of this. And then if we go to the top, do we? Oh, we didn't comment that out. But we do need to change this back. And then that's going to equal materials, that needs to equal materials. So I think that's everything in the code. But then what we need is we need our second material. So we'll go to here and we will create a new one. We're going to call this one transparent blocks, and we're just going to get rid of voxel and transparent blocks and this random skin one that was from a video that didn't get done because we don't need them. For now, transparent blocks is just going to stay as it is, and we'll drag that in. Where is it? There. Drag that in there. So this should work exactly the same way for now. Okay, the shaders work in the same way, but we have an error on our normals list. What's going on there? Oh, right. Yeah, sorry. It's less than 4. Not equal. It's I0 to less than 4, which is 3. So yeah, sorry, that should be a 4, not a 3. I'll just quickly make sure that error's gone. Right, much better. Right, so now we need our transparent material. So we'll go back into our scripts and we're going to duplicate the standard block shader. And this one we're going to call transparent block shader. And we'll open that up, and then obviously we want to change the name here, transparent blocks, and then we're going to delete all of this. No, sorry, this one we're going to leave as it is. It's the other one that we need to edit. We're going to delete all of this, change that to opaque, and then down here we want to get rid of this. So now if we go back to here and we look at our materials, you can see this is no longer transparent. And this one, if we switch it to our Minecraft transparent blocks, this one is transparent. So now we're only using transparent on blocks that need it, and that is just less intensive on the system. And if we just run that just to make sure it all works, and there we go, we have our transparent leaves and our regular ground. Forgot how to speak for a second there. So the last performance-y type thing that we're going to go over, I just want to check this because I can't remember if I did this on video or not. If you go to your lighting settings and just make sure that nothing's turned on, because we're not using any of the global illumination stuff. We're doing our own lighting in the shader, basically. So just go in there, make sure none of that is turned on, and also go into project settings and just go through this. You really don't want pretty much anything turned on, really. Soft particles can come off, real-time reflection probes. Real-time reflection probes can come off, billboard face camera position. I think that's pretty much it for stuff that we can turn on. Or disable shadows. I don't think that should, low resolution shadows should matter since we've disabled them, but you get the idea. This vsync count we're going to come back to, because I need to have a quick word about vsync count. So now some of you are going to try this and you're still going to think the game is running a bit laggy. So I just want to show one thing, because there is a reason for that, and that's the editor. Basically, if you build out the game, you will find it runs so much faster than it does in the editor. So we're just going to quickly build the game, and to do that we need to make a few little modifications to, well, we don't need to make a few modifications, but we are going to. So the first one is, if you go into our player, we go down to where we handle our inputs, which I've completely lost. Cleaner code, guys, cleaner code. We'll go down to get player inputs, and I'll just stick it at the top here. Say if input.get_key down keycode.escape application.quit. Now that won't do anything in the editor itself, but when you actually build it and run the game, this obviously gives you a way of closing the game without having to Alt F4 or anything like that. The next one, we go to the top here, and no, not the top here, sorry. We want to go here, and we want to find our in-UI function, bool thing, there it is. And we just want to say cursor.visible equals, what's this? This is in UI, so in that case it wants to be true, and then obviously the opposite down here, false. And then we're going to change here, we're just going to set in UI rather than set in the lock state in the player itself. So world.inUI equals false. Because what we were doing before, it doesn't matter in the editor because the editor works slightly differently to when it's a build, but basically the way we had it before, the cursor would have been visible in the actual build. Well, the cursor was visible in the build, I found that out. But there's no point in setting the cursor bool separately here. So all we're doing is we're making it so that this handles everything that we want to do with the cursor, and then we just set this bool. So we save everything, and we're going to go to File, Build Settings, drag that over here. So I imagine most of you have built games before. We want to make sure we add our open scene. There's the only scene we've got, so we don't need to worry about the order. If you click on player settings, you can go through all this if you want. I'm not going to mess with anything right now. I'll tell you what, I'll put my name in there. sure you get your version in there. If you want to give it an icon and all that kind of thing, a default cursor, all of that can be done in here. But that's pretty much it. Obviously, all the settings that you get in your project settings are here, so you can mess with the quality, but we've already gone over that. So once you've done all that, click build. And I'm just going to create a folder in this project folder called build, and that's the folder we're going to use. And then we sit back and wait for a little bit. This isn't always the fastest process. And there you go, it has spat out a build for us. Now, there is one thing to note, and we're going to fix this in code at some point, but that is that our... Where are we now? I'll just close that. Our settings file here, so I'm just going to open Show in Explorer. This settings file that we need, because we haven't got any other way of loading settings at the minute, does not get carried over. Now, we can put into our code a check to make sure that the settings file is there, and if the settings file is not there, to create a settings file, and we're going to do that eventually when we start really getting into the loading and saving and things like that. But for right now, all I'm going to do is load up the folder, and if you go into, if I can just remember whereabouts it puts it. Oh, that's it. Yeah, sorry. So it's the name of the game _ data. That is essentially your assets folder, or your application path as the game understands it. So I'm just going to copy it there. And if you rebuild, if you're doing it this way for now and you rebuild your build, that settings file will get deleted every time. So you're going to need to copy it over every time you build it. So if we just run it now, you can see, for one thing, the chunks are popping into existence a lot quicker. And if we go for a bit of a wander, there's no stutter or lag when we're walking around. Now, I can show you the frame rate, but it's going to be locked at around 50, 60 frames per second and everything because of vsync. So this is why I wanted to have a word about vsync. Now, vsync, broadly speaking, sort of locks your game to the frame rate of your monitor, kind of. So it's like there's no point in using up system resources to show 300 frames per second when your monitor only refreshes at 60 frames per second. So it's kind of, you know, saving your system from excess, I guess you could call it. So if I just press escape now, you'll see the game closes itself. Now, what I wanted to talk to you about with the vsync thing, if I go into, because I might need some help here if anyone out there is smarter than me or just happens to know the fix to this. If I turn vsync off and then I rebuild our game, use the same folder, this will be a lot quicker this time because it's already built it once. And before I click play, I need to remember to copy over the settings folder, settings file even. Words are easy. It's not going to look any faster because it's only the frame rate we're talking about. Things load into existence at the same time. But if I press F3 here, you can see, and I move into the light a bit, you can see that it's running at between, well, 500 and 3000 frames per second, which is a marked improvement over 50 frames per second. However, the mouse does this. Now, I did a lot of Googling trying to fix this, because obviously I wanted to show you it running at a decent frame rate rather than just 50 frames per second. And I can't find anything that helps solve this problem. There seems to be a lot of problems where enabling vsync causes the mouse to go funny, and that's usually people using time.delta time in their mouse code, which I'm not doing. But I can't find anything that's the other way around, where disabling vsync causes the mouse to do this. Now, it doesn't do it in the editor, it only does it in the build. So I can't figure this one out. If any of you know, please leave a comment or send me a message on Discord or whatever. Just be aware that I have tried a lot of very obvious things. But yeah, so as you can see though, the frame rate is far better when you build it. So that is something to consider when you're looking at the performance thing. The Unity editor itself has a lot of overhead. So that is going to be it for this video. I think the next video we're probably going to finish off all the lighting stuff, get rid of these silly black shadows and add smooth lighting. And then, I don't know, after that I'm open to suggestions. I know a lot of people want to see more detailed terrain management. People want non-block shaped blocks and items, mobs, things like that. So, yeah, leave comments below. Let me know what you think. Let me know what you want to see next. Let me know if you know how to fix this blooming vsync thing. But that's it for now. Thank you for watching, and bye-bye.